Today, we are diving deep into a technology that feels like it's been ripped straight out of a sci-fi movie. We're talking about a way to travel underwater at speeds that could rival a jet. This is the incredible science of breaking the fluid barrier, supercavitation. So let's start with our really simple question. Why is it that we can smash the sound barrier in the sky, but we can barely crack 50 knots under the waves? Well, the answer has nothing to do with engine power. It's all about the stuff you're trying to move through. And here is the core of the problem. Compared to air, water is just incredibly dense and viscous. Trying to move through it is like trying to sprint through a swimming pool full of honey versus, say, a light fog. Every single inch of movement means you have to shove an immense amount of fluid out of the way. And the difference is just staggering. Water is about 800 times denser than air. To put that in perspective, imagine trying to go for a run after strapping 800 backpacks to yourself. That's the kind of insane resistance an underwater vehicle is fighting against every single second. All that density and viscosity create what engineers sometimes call an unbreakable water wall. It's this combination of skin friction, where water literally sticks to the hull, and form drag, which is just the sheer effort of pushing it aside. It becomes so powerful that even our most advanced, powerful nuclear submarines just can't punch through it to get to those higher speeds. So, if you can't go through the wall, what do? Well, you get clever. You find a way to not touch it at all. And this is where the big breakthrough comes in. You learn how to ride inside a bubble. The fancy term for this is supercavitation. And what it means is you're intentionally creating this huge, stable bubble of gas that completely wraps around your vehicle. So now your hull isn't grinding against that dense, high-drag water anymore. Nope, it's touching low-friction gas instead. And that is the absolute genius, totally counterintuitive idea at the heart of all this. You're not trying to push water out of the way. Instead, you're literally flying through a pocket of air that you carry with you, deep under the ocean. And you can see just how ridiculously effective this is. By swapping out that water-to-hull contact for a gas-to-hull contact, you can slash the hydrodynamic drag by over 90%. It's not just an improvement, it completely changes the fundamental physics of moving underwater. Okay, so how in the world do you actually build a machine that can pull this off? Let's take a look at the anatomy of one of these things. Because really, what you're building is an underwater rocket. It all boils down to three key parts that have to work together perfectly. First up, you've got the cavitator. Think of it as a sharp, flat disc right at the nose that parts the water so violently it creates a void, an empty space right behind it. Second, you need a gas injection system to pump exhaust gas or compressed air into that void to keep the bubble big and stable. And third, well, a normal propeller would just be spinning uselessly in that bubble, right? So you need a rocket engine to actually push you forward. But solving one problem creates a new, massive one. If your vehicle is flying along inside its own private bubble, not even touching the water, how on earth do you steer it? This is what we call the steering paradox. I mean, really think about that for a second. A boat uses a rudder to push against the water. A plane uses its wing flaps to push against the air. What do you push against when you're flying through a vacuum that you created yourself? Right. Your rudders are now inside the bubble with you, so they're completely useless. And if you try to stick some fins out of the bubble to touch the water, they create such enormous drag and instability that they could rip the bubble and your vehicle apart. But engineers have come up with two really clever solutions. The first is gimbaled thrust. You basically just steer by tilting the entire rocket nozzle, just like they do on a space rocket. The second method is called cavitator pitching. This is where you actually tilt that little disc at the nose. By doing that, you change the shape of the bubble itself, which then forces the craft to follow the new curve of its own gaseous cocoon. Pretty smart, huh? But even with these solutions, steering is incredibly dangerous. There's this constant risk of something called tail slap. This is when the back of the vehicle accidentally bumps into the inside wall of its own bubble. It can cause a violent, chaotic bounce off the water wall that can literally shake the vehicle to pieces. It takes incredibly fast and advanced control systems just to keep it flying straight. So, is all of this just wild theory and lab experiments? Not even close. Let's take a look at how supercavitation has already been used in the real world, and where it could be headed next. You see, this tech was actually weaponized decades ago. I want you to meet the Russian VA-1111 Shkval torpedo. It was developed way back in the Cold War. It's a real, deployed weapon, and it is absolutely terrifyingly fast. How fast are we talking? 200 knots. That's over 370 kilometers per hour. To give you some context, that is nearly 4 times faster than its Western counterparts. It is so fast that it's designed to simply outrun an enemy submarine's ability to even get out of the way. But the future of supercavitation could be about so much more than just weapons. The ultimate dream, the holy grail, is to apply this tech to transportation. Just imagine a submerged transatlantic express train. So let's look at how this could all play out. Today, we've got the 200-knot torpedoes. The near future might bring us things like defensive underwater drones that use this tech to intercept those very torpedoes. But the dream? The final frontier? A vessel that could get you from New York to London completely underwater in less than 2 hours. Now, of course, we have to be realistic. There are huge, huge hurdles to overcome before that dream becomes a reality. We're talking about extreme noise pollution, immense fuel requirements, and developing guidance systems and new materials that can even handle the insane heat and pressure at those kinds of speeds. So yeah, a 2-hour underwater trip to London might still be a ways off, but the science is real and the journey has already begun. Supercavitation proves that the unbreakable wall of water really isn't so unbreakable after all. I think this quote sums it up perfectly. It's a technology that truly promises to transform one of our slowest domains into our next high-speed frontier.